Alrighty, so in this video we're going to do a little lab 1 recap as best I can without missing anything in one take. So let's jump into it. So they kind of intro you to plugging in values into cells and plugging in functions into Excel. So they just start you off with like plugging in 3, 5.1, and this -7 value, making the labels up here. Typically they might want the labels in bold, whatever. So in the second column, they have you practice typing in functions. So the idea is to input this function of 2x, right? So 2x is just 2 times whatever you're inputting for x. So for the function of f of x, we would input equals 2 times a2. So a2 is in our x column, and that's the value we're doubling, right? And then really they have you type in each of these formulas you can see up here individually, just to double each of these values from left to right. So they have you do that. Then they have you try with kind of a crazier formula at some point. There it is. So this g of x, so x times x squared minus 4 to the 5th, and they have you input that here, and they have you still use this function to act upon the a2 value. So at the start we're plugging in a2 wherever we see x in this function, right? So x on the outside, a2 times x squared, or a2 squared minus 4 raised to the 5th. And then if you wanted to, you could input those individually, but what they also teach along the way is if you input this function once in C2 in this big cell here and hit enter, and you click and drag this corner down, then it'll fill in these values automatically for the corresponding A3 cells and A4 cells. So you can see for this cell here, you can see its formula uses A3 and A3 automatically, just like C4, this cell, does as well. So anyway, and then they have you actually demonstrate that in this column H. They have you double those A2 values, those column A values, I mean. So basically they just have you type it in once, and then you drag this down to fill in the rest of those values corresponding to 5.1 and -7 respectively. So let's keep going through this. Okay, so then they kind of introduce the functions e to the x, and then t times e to the yada yada, just more complex e functions. So the biggest takeaway is that to type in e to the x, you will use equals exp, and then whatever's in the exponent of the e function, you put just in parentheses. You don't need to raise it to any power. It's just exp parentheses, whatever you're putting in the exponent. So that's why for this exponent here, -0.35t, they've done exp and then just parentheses -0.35 times not t but a1. A1 would correspond to whatever the t value is that you're plugging in. Then here they're just telling you to make sure you're watching out for parentheses. Like if you're putting 3 times 2 in the parentheses there, you want to make sure you have parentheses, in the exponent there, you want to make sure you have parentheses around everything you're putting in the exponent. That's pretty much it. Here they have you practice writing out what these functions would look like within Excel. So I actually did those here. It was kind of unnecessary, but I'll just click through these one by one. So keep in mind this first one's corresponding here, second one here, third one, and so on. So 108 comes from this formula. You can see those formulas up top there. Right here, right here, right here. All right. And they have, again, all those answers right down here, just upside down. All right, let's keep going. Automation in Excel formula. So automation, excuse me, was the whole dragging down and filling in the formula values without having to retype the formula in over and over. So it's dragging the corner down like we did earlier. Input data. So this is kind of another automation thing. So they tell you to click on sheet 2. So down here you would click on add new sheet, add new sheet. I think I just, okay. So anyway, we don't need this sheet, but that's how you introduce a new sheet. Let's delete that one. So then we have sheet 2 here. And what they tell you to do is like, label this t column, and then you input the value of 0. And then in order to kind of like grow these values in increments, instead of typing 0.5, what you do is just use a formula to increase the value by certain increments each time. So we click on A2, so we do like equals A2, and then we add 0.5. And then once we have that formula, we can drag it down to fill in these values. And if we wanted to, we could keep dragging it down to fill in more values, adding by 0.5 each time, right? So then they have you do a new pattern where you go from like 2 to 10, I think. Yeah, so 2 to 10, but going up by increments of 0.1. So starting at 2, and then in this cell you actually input the formula C2, referring to the previous cell, plus 0.1, and then once you have it typed in here, you can drag it down all the way to 10. And of course, if you wanted to, you could keep going. Yeah. All right. Where are we? Let's see. We did that, and then here they're talking about inputting all the formulas, those like crazier formulas we saw on the last sheet right here, but actually using values and plugging them in. So I'll just kind of make this bigger here. So they have you go from 4 to 5, doing the formula increments like we just talked about, and then inputting each of these formulas. So these formulas come from the previous page, so you can see them across the top. Let me go ahead and just put that back. So we see our first f of t is 3t squared, which you can see up there, how that makes sense. And then we have the second f of t, which we see here. It's a little more complex, 10 over 2 plus 4t squared. So you can see where I've typed that in up here. And then ignore the percentage thing for now. I'll talk about that in a sec. And then here, r of t comes from this e function down here. So we can see the exp playing a role. And the last one, the m of t, we see 5 times t e to the 2t. So a little crazier, but that should be it up here. All right. So then with these, they just say like double check your work, compare it to the lab 1 samples along the way. Make sure to do that if you want. And then they talk about rounding numbers to certain decimal places and converting to percentages. So real quick, at some point they tell you to like round this column to 1 decimal place, this one to like 4, this one to 2, this one to 3. So what you do is you can just click on this column and then go to format cells, and then you go to number and then decimal places. So you can like increase the number of decimal places accordingly, however they want. And then in this column, what they actually made you do is convert the G values to a percentage. So you also go to format cells, and you click on percentage down here, and you can change the number of decimal places that percentage has. So one more thing, if you don't want to go all the way to format cells for certain decimal places, I think what you can do is just highlight a cell, and someone showed me this last semester. You can kind of just, so I guess you can't highlight the whole column, but you can highlight the values here, like, neglecting the m of t, and you can kind of like move around the decimal places just with these buttons up here, so that's kind of convenient, right? Let's get back to the lab document. They talk about graphing. So open a new spreadsheet. Okay, yeah. So they just have you practice, I think, just doing this. I think these values come from the lab samples. They tell you to like, input these values using formulas. You can see the formulas across the top here. Drag them down, and then they tell you to insert a scatter plot. So they tell you to do t's and y values. To insert a scatter plot like this, what we do is highlight these cells. You could highlight like I just did, like click and hold and drag across, or you can click on T and drag it and highlight those like that. But regardless, we'll go to insert, and then over here at the charts, we'll go to the scatter plot image, insert scatter, click on that, and just go ahead and click on this first one here. And again, we can just delete that old one. That's all it is, just inserting those points on a graph. And then I think that's pretty much it. Yeah. So then interest compounded continuously. So they're talking about this function here. And what do they want us to do? So this is the interest tab. So you add a tab, and then you can double click right here where my mouse is to change the name and hit enter, yada yada. So I'm going to get rid of this graph real quick and talk about this. So T years and F of T dollars. This comes from how they tell you to label it somewhere along the way. Yeah, somewhere in here. I don't know. I can't see it now. But they tell you to start at 0, and we're going up to something. Let me see if I can find it. So starting at 0. Yeah, there it is. T years, F of T dollars. Use formula to enter the years 0 through 5. So we started off lightly with 0 through 5, and starting at 2100. Well, 2100 actually comes from plugging in this equation right off the bat. So right in that first B2 cell, we're inputting this function. So you can see the function typed in here, and then we just drag that down through time 5, right? And then they say what's the result in B7. So we can see in B7 we have 2501. 2501's upside down right here. Then they say you may need to extend your formulas to answer these following questions, right? So they say if you invest 2100 in this account in the year 2019, how much money will there be in 2040? So what they're basically saying is if you invest 2100 at the start in the year 2019, then time 0 basically corresponds to the year 2019. So then they ask how much money will there be in 2040. So let's keep going with this. At time 5 here, once you only have it filled out to this, you can actually highlight both of them simultaneously and drag it down as far as you want, really, to fill out all those other ones. But if you're confused about like how to find which t value corresponds to which year, you can kind of make a column of years here if you wanted to sort of help you out. So you can do like 2019 plus 1. Another way, and then you could drag those down to fill in the years, right? Another way I might recommend doing these. Oh gosh, sorry. There we go. Another like pattern trick is typing in the next value or whatever pattern you want. You can highlight both these cells, and then it'll pick up on that pattern, and you can actually see like the year that it's corresponding to. So we could drag this down until we see the year 2040, right? Because 2040 is correspondent to time 21, which corresponds to an investment value of 43.7951, which we do see 43.7951 as the answer to number 2 here, right? So then how many years will it take for your investment to reach 10,000? So then we highlight, both columns, we drag it all the way down until our investment value is over 10,000, right? So it wouldn't be in this year that it's 10,000, but just after that next year it's crossed over that 10,000 mark. So they just ask how many years have to go by, but if you wanted to, you could also figure out in what year that would happen. Oh, so there's a mistake I made there. So rather than just highlighting 2040, you need to highlight both of them if you're using this method, not the formula method, but the kind of pick up on the pattern method. So anyway, you'd hit 10,000 in the year 2064, but they just want to know how many years have to go by, which is represented by the time value, so 45. So you'll see t equals 45 here. Scatter plot of the data. So they want us to input a scatter plot. So let me do this big. We'll highlight both these columns. We'll do insert scatter plot like that. And we get this curve here, and I think they ask like what's the shape of this curve or what kind of function is this, and this is known as an exponential function because we used an exponential function to get these y values, and it just has that curvature. It's growing exponentially, so this is an exponential function. All right, hopefully this is still recording and not messing up. I think we're doing all right. I have no idea how long this is, but all right, like 14 minutes, not bad. Okay. I'm getting close here. Linear models. Let's see. I might stop this just to... no, we're going to keep going. Screw it. All right. So, linear models. They tell us to use the lab data now. So, looking at the lab data, they tell you to, across the bottom here, make sure you start at data sets 1 and 2. So we're going to talk through a lot of these briefly real quick. They tell us to highlight these and insert a scatter plot. So make sure to insert a scatter and then highlight these two and insert a scatter. We see this data, right, and this plot over here. We see this data and this plot over here. They're asking about linear models. So when you look at these scatter plots, one of these obviously has a more linear or looks like a line behavior than the other. And so data 1 has a more linear behavior while data 2 is just, super scattered. Then they talk about correlation of x and y values. So correlation just basically means like how closely related are x and y. And the R value, the correlation value, ranges from -1 to 1. The closer the correlation value is to 1 or -1, the more correlated the x and y values are, the variables are. And so they tell you to like find the R value for this set and the R value, the correlation value for the second set. And we can do that with this correl function. So I'm going to demonstrate that real quick. With this first data set. So we hit equals, we type correl, and we, rather than highlight all of this, we highlight the x values, then we type a comma, then we highlight the y values. Close off the parentheses, hit enter, and this gives us this decimal of 0.995 if we round up. 0.995 is very, very close to 1, which means the x and y values are very closely related, right? And we can see that visually in this plot because we see a very linear function. Now, in the second one, in the second set of data, we find an R value of like -0.05, which is very close to 0. And the closer the R value is to 0, the no correlation. There's no there's the least amount of correlation between x and y, right? So and we can see that in the graph, right? There's barely any correlation. Another thing to point out is when R is positive, the line will have a positive slope. When R is negative, the line will have a negative slope. You can barely see it here, but we still see it across that line there. Another thing is when you insert scatter plots, they talk about adding trend lines. You'll click on this chart, maybe double click. Yeah, double click. Go to add chart element, go to trend line, more trend line options. And sometimes it'll pop up here. You want to make sure to click on these bars here and then hit display equation on chart. So display equation, this is a trend line or a line of best fit or a linear regression. There's a bunch of different words for it. And it basically gives you that line of best fit that goes through these points, and they tell you to do it for this one as well to get these, y equals mx plus b functions, these line functions. All right, I'm just going to keep winging it off the rest of this. So for the next section, they talk about increasing the price of a Samsung phone and how that will affect the likelihood that someone's going to purchase it. So the question is if they increase the price of a Samsung phone, will people be likely to buy it? So they give us 3 sets of data, so 3 different surveys, I suppose. And with each survey, they want you to find the correlation value. Again, I'll demonstrate it in the last one, but we use the correlation function, correl. So we find that, and then they want us to insert a scatter plot, for which we can just I would highlight all these like that. So starting from the titles all the way down to the last 7, and then insert scatter plot, yada yada. And they also want a trend line for each one of these. So, and then they also ask for that first one. Once you get the trend line equation, what does that look like? What does x and y represent in terms of price and likelihood? And then if we were to sell a phone for $574, what's the likelihood that someone would buy it? So let's talk about this first. If we look at this scatter plot and we see prices are in the 600s, 700s, 500s, 600s, and then we look at the purchase likelihood and they're at 3 to 7 range, right? And we look at the x and y values on our chart. Well, if we have 5 to 6, 700 here, we can tell right away that these x values must be the prices. And on the y values in the 1-digit range, the y values must be the purchase likelihood. So that's how we come up with this y equals mx plus b or L equals mp plus b. equation. So really just rewriting this equation in L and P. Then you plug in the 574 for P to get this L value of about 5. So if the price is 574, the likelihood that someone's going to buy it is about 5, which is pretty high. So anyway, do the same thing for survey 2, get the R value, get the scatter plot. Looks a little crazy on mine, not really sure why. And then I'll demonstrate it for this last one. So Corel, again, highlight just the numbers for the first column, comma, numbers for the second column, close parentheses, hit enter. Pretty high correlation value, pretty close to 1, positive. So what we're going to do, we're going to highlight all these. We're going to go to insert, scatter plot. We can see a nice positive, slope there, positive correlation. We go to add chart element, trend line, more options. We already have linear selected. Then we go to display equation on chart. And so we have this equation for this trend line going through those points. So anyway, I think they ask like which of these is most likely to happen in real life and which ones, what situation could you give for the other two? I would just say the first one's probably the most realistic. And let's talk about why. This correlation is negative and it's pretty strong. The correlation is negative because there's a negative, and the correlation is fairly strong because this 0.7 is fairly close to 1 in terms of like absolute values. And so what this is saying is as the price, we can kind of see it on this graph, as this price increases from 500 to 700, the likelihood that people are buying this phone goes down. So as price goes up, likelihood of buying goes down. That's why there's a negative correlation, and that's why I would say it's a more like realistic scenario. Now, I think that's the answer they want, but to be honest, people are buying iPhones for like over $1,000 and they're cool with it, so maybe it's not super realistic. Anyway, this one is negative 0.07. It's a value that's kind of close to 0, which means there's no connection, there's no correlation between these variables, the price and the purchase likelihood. So that's not very realistic. Maybe that's the most realistic because there's no connection. I don't know. And then this one's very positive. This would be just not realistic at all. Well, maybe I don't know. I'm still on the fence about it. But maybe you could come up with scenarios where like as the price goes up for something, someone would be more likely to buy it. I don't know. Yeah, I'm going to leave it at that. I hope that covers a lot. If you have any questions on this, please let me know. Thanks for watching. All right.